ways and due to the setup of the equation, they will always equal the same thing no matter.
Let's just review for a moment what slope is. Slope is rise over run. Now here, I can switch them, but I got to switch it in top or bottom. In other words, I can do y sub 1 over y sub 2 as long as I do the same thing in the bottom. I cannot switch them if I switch only the top. I'm going to end up with a slope that's got the wrong sign on it. Okay? So when you're dealing with slopes, you can do that, but notice you have to switch them both. When you're dealing with the distance formula, you don't care. You can switch just one of them and it'll be fine. Because we're squaring it. With slope, we don't square it. With distance formula, you're going to square it after you do that subtraction. Okay?
When you square something, it's always going to come out positive.
Yeah. And more importantly, when this is probably the key piece of math to really know, and that is that a minus b is always the negative of b minus a. Think of it. 5 minus 3 should be the negative of 3 minus 5, and it is. They're both 2.
Yep.
Okay. So, therefore, whenever you're doing this distance formula, it doesn't matter if I have x sub 1 minus x sub 2 or the reverse. I get the same numbers, just one has a negative sign, the other has a positive sign. But that sign difference disappears after I square it. So it really doesn't matter. I can do it this way just fine. Okay, now...
No, it's the commutative property. Figure that out. Sorry, that was my own little...
Okay, that's fine. So let's see. We figured out that HF was equal to 3. And now using the distance formula, let's figure out what GF is.
Okay.
What's the difference in the x coordinates?
Okay, so the difference in the x coordinates is 3, sorry.
3, so it's 3 squared. What's the difference in the y coordinates?
1, so it's 1 squared.
That's the square root of 10.
Yeah.
That's the distance for GF. Now let's figure out GH.
So, the difference in x value is 3. And the difference in y value is 2.
That's the square root of
13 squared. 13.
So the root, yeah. You get root 13. Okay. So now, what's that?
You get square root of 13.
Right, and that's the final answer. In other words, that does not simplify, nor does square root of 10.
Yes.
I could turn square root of 10 into square root of 2 times square root of 5, but that's not a simplification. That's 2 terms instead of 1. So if I cannot pull a whole number out of it, I cannot simplify. Okay? So here's our 3 distances. Well, can we find those same 3 distances with the red figure that it's mapped onto? Well, let's take the one, RT. RT is equal to what?
RT is equal to 3.
Which is the same as HF. Okay.
Yes.
Now let's take RS. RS is equal
to these is equal. It doesn't matter due to the commutative property of addition. It doesn't matter. So
doesn't matter
square root
delta x first,
1.
Delta y. Yeah. So it's
the square root of 1 plus the square root of 3.
3 squared.
Which equals the square root of 10.
Right.
Which equals GF.
Correct. You only have one other to check, and that's ST.
Then, So the square root of 2 plus the square root of 3.
Don't forget to square each one of them inside.
Yeah, no,
Square root of 2 squared plus 3 squared, which is the square root of 13, which is the same as GH. So you have that side equal to that side, that, by side, side. They are both congruent. They are isometries. I think that's how it's pronounced. Isometry. Yeah. I think the emphasis goes on the S-O-M, isometry, I believe. It's the only way it makes sense to pronounce it. Okay. So you know how to do the distance formula. In other words, 33 is the same. We're going to have to use the distance formula. And I can immediately tell that BC is the same length as ZY. Why? Because the Y coordinates are separated by 1, the X coordinates are separated by 3. Same thing over here.
And you can do the same thing for ZX and CA.
Yeah, so I don't actually have to go through the distance formula. Unless they said, show my work, I know that they're congruent just by looking at these distances and slopes and angles and differences of the Y coordinates.
They're just reflected over the line x equals -1.
Correct. Not x equal negative. Yes. No, you're absolutely right. It is a reflection over the line x equal -1. Okay. Let's see. Let's look down at the bottom here. Okay. Given that we're looking at an isometry, how do I solve for some of these variables? In other words, the first variable to solve for would be... Okay.
So you can already assume that 96 equals 2a.
Okay, so 96 equals 2a, giving you an a of...
Yes. So giving you an a of 48. B equals 92, that's straightforward.
Okay, b equals 92.
And 6 equals 3d, giving d a monetary value of 2.
6 equals 3d, d equals 2, and
then c equals 7.
Yeah.
But that's all we can find.
Well, that's all that's needed. There were only 4 variables there, so yeah, and it's helpful. You know, I don't really like these arrows. I guess that arrow means it's an isometry, but it doesn't give you any other information at all. It doesn't tell you whether it's a slide, a glide, a reflection. It just tells you that it's been mapped on to the other.
Okay.
I guess that's okay. In other words, 35 is an isometry with a rotation.
So we already know that there's a right angle in there.
Mm-hmm.
And we also know that 2y equals 6, giving y a value of 3.
Okay.
We also know that 2w equals 70, giving w a value of 35. Good. And lastly, we know that 3x plus 1 equals 14. So subtract 1, get 13, and divide 13 by 3.
Very good.
Which would equal 4 1/3.
Very good. Actually, leave it as a ratio. It's something I'm trying to tell people. In other words, in early math, they act like that is superior to this.
Yeah.
But in later math, ratios is what it's all about. When you get to trig, you would never use 4 1/3. You would always use 13/3.
So mixed numbers are not prevalent in trig.
Correct. Improper fractions are the rule in higher math. And starting kind of with geometry, I would even say. Either answer is correct. It's just that when you get into higher maths, this one will help you more than this one.
One's more useful than the other.
Yeah, it is. In fact, a lot of times if you're given the mixed number, you have to convert it to an improper fraction to proceed. So,
which is pretty easy.
Well, it is easy, but might as well leave it as the improper fraction to begin with.
Yeah.
All right. Well, that's all of the problems on that page, and by the time I could take another picture and load it up, we'd be just about out of time. So why don't we just do a 45-minute session today?
Okay.
That sound good?
Yep.
Okay, I'll do that and tell your brother I'll be with him in 15 minutes.
Okay.
All right. Have a good one, Bolton.
Yeah.
Bye-bye.